Welcome to this session of geometry, and today we will look at how to construct a similar triangle. But before that, let us quickly revisit the concept of similarity when it comes to a triangle. So, if we have been given a triangle, when can we really say that any other triangle is similar to this one? We have learned in our previous session that it happens whenever corresponding angles between them are same and corresponding sides are in the same ratio. And as long as these criteria are satisfied, size of the triangle won't matter. It can be bigger than the given triangle or smaller or even an exact photocopy, right? And also, it won't make a difference if we, let's say, rotate this similar triangle in any of the direction, because these criteria will remain the same no matter what. But in today's session, we are going to do something different. We will learn how to construct a similar triangle when we do not have any information about these criteria. And all we have been given is a triangle with some dimension. And we also know something called as a scale factor. Now, what is a scale factor? It is a ratio that gives us an idea about how big or how small a triangle has to be. For instance, if we draw a line segment AB of length 9 cm and we wish to get another similar line segment, but it should be just 2/3 of this one, then what we can do is form 3 equal portions on this line segment and just consider length equal to 2 portions, that is 3 plus 3 equal to 6 centimeters. Thus, we say AB has been scaled down to form CD by a scale factor of 2:3. But did you notice when we consider 2 equal portions, the line segment AB actually gets divided in a ratio of 2:1. So this is where we have to be careful. We should not make any mistake while dealing with these two kinds of ratios, because scale factor only indicates about the size, whereas the other one is only a dividing ratio. In the same way, if we consider triangle ABC, then sides AB, BC and AC are just like line segments. And if we divide each of them in a ratio of 2:1 and use only these two portions from each of the sides, then we'll be able to construct a new triangle, which will be just 2/3 of this given triangle. And naturally, it will be smaller in size. So, this is the logic we will be using in this session. So, for the construction of a similar triangle, we will have certain requirements. The first requirement will be a compass, which is the name for a geometrical instrument. Do not confuse it with the one we use for following directions. And we will also require any kind of instrument that will just help us to draw straight lines, and it will not have any markings on it. For example, a straight edge. So now let us go step by step and understand all the steps of construction. First of all, we have to consider any side of the triangle to be divided first. Just for the convenience sake, I am taking the side BC. But we cannot directly start dividing the side BC in 3 equal parts, because remember, we only have to use the compass and not a measuring scale. So in such a case, we can't take a risk of dividing BC inaccurately. And since geometrical construction is all about drawing accurately, so we'll have to take appropriate measures. So instead of directly initiating construction on a triangle, we will draw a ray, and this will be our step number 1. Draw a ray from any of the vertex of the triangle. So let's say in this case I draw it from vertex B, and on this ray we will start the construction we intend to do. Now please note, this ray has to be at a shorter distance from the side BC, which means the angle between them should be small. Now this is a crucial point to remember, because later we'll try to connect this ray BX with the side BC by some lines, and that proves to be easy and convenient when the ray is closer to the side BC. When this step is done, we have to place the pointed arm of the compass on the vertex B and cut an arc of appropriate length on the ray BX and label this arc as B1. Now this length on the compass can be of any measure as per our convenience, okay? So whatever measurement you choose, maintain the same on your compass and place it now on B1. And now cut an arc and label it as B2. Repeat the same by placing the compass on B2 this time and make a new arc named B3. So by the end of this, what we'll get is the length BB1 will be equal to B1 B2 and that will be equal to B2 B3. Now step 3 is to join B3 with the vertex C. So we'll get a line segment B3C. And since we want to isolate two equal parts, we should even draw a similar line segment from the point B2. Now you guys tell me, can I draw it like this or like in any other direction? No, it won't be correct because that way we can see the side BC of the triangle doesn't really get divided in a ratio of 2:1 that we intend to divide it into, right? So we have to be cautious, particularly while drawing this line segment from the point B2. It should be done in such a way that it proves to be parallel to B3C. And for that, all we have to look into is the angle between the ray BX and B3C and maintain the same angle over the point B2. Now, it would be really easy to do that with the help of a protractor or any other instrument that readily measures an angle, right? But yet again, I should remind you, we just have to use a compass and nothing else at all, even for this purpose. And that's where lies our real challenge and the trick. So let me show you how we can do it. Draw an arc of appropriate length with the compass from point B3 so that it cuts the ray BX and B3C. Repeat the same on point B2 by keeping the same measurement on the compass. Now come back to the arc we made earlier from B3 and measure the length of the arc from the point it touches BX to the point it touches B3C. Now keep the same measurement intact on the compass. Cut another arc on the arc we made from the point B2. And now with the help of a straight edge, if we join B2 with this arc intersection and then further extend it to touch the side BC, say at point D, then not only will this line segment B2D will be parallel to B3C, but also the side BC now has been divided in a ratio of 2:1. Now we can check this by conventional way of taking a scale with standard markings and measuring the lengths. So if let's say BC was 12 centimeters, we must get BD as 8 centimeters and DC as 4 centimeters because that is the 2:1 ratio. Okay. Or the second way to prove this is if you recollect the well-known basic proportionality theorem or BPT, which says if we pass a line through a triangle in such a way that it is parallel to one side of the triangle, then the other two sides will be divided in the same proportions. And if you notice, that is exactly what is happening here. If we consider B3C as one triangle, then the line segment B2D cuts this triangle in such a way that it's parallel to the side B3C. And if we take the ratios of these divided sides of the triangle, what we will get is a ratio of 2:1, which means we have successfully secluded two equal parts on one side out of the three equal parts. Now, the last and the final thing that remains after dividing the side BC in a ratio of 2:1 is to divide the whole triangle in the same ratio. Believe me, this part is really easy. All we need to do is repeat step number 4 on point D, just like we did on point B2, and make a line segment parallel to the side AC this time by maintaining the angle between the sides BC and AC. And this way, we'll be able to divide even the side AB in a ratio of 2:1. And let's call this new point as E on side AB. So, can you notice this smaller triangle EBD within the given triangle ABC? This is the similar triangle that we were trying to obtain with the given scale factor of 2:3. And just in case if you'd like to try to see if really triangle EBD is similar to triangle ABC, then you can make use of a measuring scale and measure each side of both the triangles. I'm sure you'll find the length of each side of triangle EBD to be 2/3 of the sides of triangle ABC. And that's the beauty of this construction. Even without really knowing the angles and the measurements of sides, we could find a way to construct a similar triangle accurately even then, with the help of instruments like compass and straight edge. So please hit like if you have understood how do we construct a similar triangle, and post any of your queries in the comment sections below. And for more such videos, do subscribe our channel. Let's do. Keep watching, keep learning.